Integration by substitution. So this is another complex method that you might want to choose to use. Now look at this expression, and again when you first see it you think, oh blimey, but this one's actually okay. This isn't that complicated. I think of this as being similar to the chain rule. It's similar to function of a function. Look at these. If you're asked to evaluate these, how would you go about doing them? Well, clearly it's not a simple integration, and it's not just two terms multiplied together. It's almost like there's a function of a function thing going on. So how would you go about doing it? Well, what we'll do is we'll substitute some of it for u, where u is a simple function of x, so that when we differentiate u and we do a bit of cancelling, we put it in the expression above, we get something much easier to deal with. Again, if we look at some examples, hopefully it will become clear. So, for example, evaluate the integral of x into 3x squared minus 1 to the power of 4. At the moment it looks like a nightmare, so let's say that u equals, can you guess what u will be? Let's say that u is 3x squared minus 1. So if u is 3x squared minus 1, then du dx is 6x. And what we do to sub into the expression is we want dx du, which is 1 over that. So 1 over that is 1 over 6x. Let's put them together and we get the integral of, well, f of x dx, the integral of y if you like, is the original expression times 1 over 6x du. And very conveniently those two x's cancel and we're just left with the integral of u to the 4 over 6 du. Integrate that and it's u to the 5 over 30. Substitute for u again and we get the answer. Here's another one. Evaluate the integral of 2x sine x squared dx. So let's make u as, of course we'll make u equal to x squared, so that du dx is just 2x and dx du, 1 over that, is 1 over 2x. Then if we substitute that in the expression above into the right hand side of the expression above, very nicely again the x's cancel, in fact 2x cancels, and we're just left with the integral of sine u du, which is of course minus cos u plus c. Don't forget to sub in u again, and the final answer is minus cos x squared plus a constant. We'll look at another one together. Evaluate the integral of x plus 1 cubed dx. So to make it simpler, we're going to say that u equals, well done, we'll say u equals x plus 1, so it just becomes the integral of u cubed dx. So du dx is just 1, and dx du therefore is just 1. And if we sub it in to the right hand side of the expression above, then it's the integral of u cubed du, which is u to the 4 over 4, which is that. Okay, here's a few for you to have a go at. So clearly it's a complex expression. It's more than just two things multiplied together. It's like a function of a function, and the first thing to decide is u equals something. I suggest you pause the video, have a go at these yourself, and I'm going to show the answer in 3, 2, 1. There you go. And the second answer, 3, 2, 1. And the third answer, 3, 2, 1.